Okay, today we're looking at forms of heat transfer, and in particular we want to find out about this form of heat transfer that we call conduction. There are two other forms of heat transfer, convection and radiation. The important thing to remember in any form of heat transfer is, as we've talked about before, that heat can only go from yes, you remember, a hot place to a cold place. And if you've been listening carefully in class, you will know that a hot place has a high temperature and a cold place has a very low temperature. And temperature is all about the particle motion. So down where the temperature's hot, the particles are moving around really quickly, and off they go. And where the temperature's cold, the particles are hardly moving at all. So we're going from a place where the particles have high energy to a place where they have very little amount of energy. It's really hard to write energy small on this little tablet. So what's happening in conduction then? Well, let's have a look at these particles up at this end, the hot end of the object. These particles are moving around really quickly because they've got lots of energy. What happens when particles move really quickly? It's a bit like people in a crowd. When the particles move backwards and forwards, guess what happens when this one moves over here? Yep, that's right. It makes that one move. And so if that one's moving faster, what's happening to its temperature? Right again, temperature starts increasing. And guess what that one does? It moves more. Spot on. Bumps on into the next one. And we're done getting that energy all the way along, bumping into each other all the way along until eventually that hot, cold end becomes hotter. So then, what is it that makes conduction happen easily? Well, you will have spotted that the particles need to bump into each other. So conduction occurs best where particles are close together. And some of you will have picked out that particles are closest together in, you remember, solids. So conduction is best in solids. They're a bit close together in liquids, but there are problems with liquid conduction in liquids. And remember, in gases, they're really far apart. We'll have a look at those in just a moment. The other thing that helps conduction is when these solids have free electrons. And we'll find out about those a little bit later on. But that happens really well in metals like copper and iron. Back in liquids, remember the particles are already free to move past each other. And so when they're moving around quickly, although they bump into each other, the energy doesn't always get passed along through the liquid in the same way. So conduction doesn't happen so well in liquids, and in gases the particles are so far apart they hardly bump into each other at all. Gas conduction, no, doesn't happen. Only really well in solids. And my time's up.